بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 2.5 continuity. From the given graph of f, state the numbers at which f is discontinuous and explain why. So, and for each of the numbers stated in part A, determine whether f is continuous from the right or from the left or neither. Okay, so we will determine the numbers at which f is not continuous. We will explain why, and we will tell also whether continuity from the right or from the left. So the first number we consider is negative 4 because f of negative 4 is not defined. So f of negative 4 is not defined. Hence, f is not continuous at x equals negative 4. It is neither. This is we can say this is part A and part B neither. I mean, it is not continuous neither from the right nor from the left of negative 4. Now, x negative 2 at negative 2, what's happening? F of negative 2 is defined, but the limit does not exist. So the limit of f of x when x approaches negative 2 from the right is not equal to the limit of f of x when x approaches negative 2 from the left. So the limit of f of x when x approaches negative 2 does not exist. For part B, for this number x equals negative 2, but we have the limit, notice that it's closed here, okay? So the limit of f of x when x approaches negative 2 from the left, when x approaches negative 2 from the left, this would be equal to f of negative 2. And that's the definition of continuity from the left. So f is continuous at x equals negative 2 from the left. Okay, from the left. Okay, let us go to another number. 0, it's continuous. 2. At 2, the function is not continuous. You can notice that, similar to negative 2, the limit does not exist at 2. So f is not continuous at x equals 2, since limits f of x when x approaches 2 does not exist. But we have the limit of f of x when x approaches 2 from where? From the right. Okay, when x approaches 2 from the right, the function approaches this number, which is f of 2. So limit of f of x when x approaches 2 from the right equals to f of 2. This means f is continuous at x equals to 2 from the right. So it's continuous from the right only, but from the left it's not continuous. That's why it's not continuous in general. So f is not continuous at 2 in general, but it's continuous from the right. Okay, to be continuous, it has to be continuous from the left and from the right. Now for 4, also at 4, it is not continuous because the limit does not exist. while when you approach 4 from the right, the function approaches f of 4. So it's also continuous from the right of 4. So f is not continuous at x equals to 4 in general, since the limit of f of x when x approaches 4 does not exist, because the limit from the right is not equal to the limit from the left. From the left, even it goes to negative infinity. But for part B, limit f of x when x approaches 4 from the right, okay, from the right, equals what? Equals f of 4. And this means that f is continuous at x equals 4 from the right. Okay, and that's here determine f is continuous from the right or from the left. So we answered, we found all the numbers and we discussed the continuity from the right and from the left for each one of them. The graph of a function f is given. At what numbers a does limit f of x not exist? Let me answer here part by part. So at what number a does the limit not exist? So the limit does not exist at 1, okay, at 1, because the limit from the right is not equal to the limit from the left. I think it's only 1, because at 3 the limit exists. Okay, so that's the answer. At what numbers a is f not continuous? Well, f is not continuous at 1, and it's not continuous at 3 also. At what numbers a does limit f of x exist, but f is not continuous at a? At 3. The limit when x approaches 3 exists. It's equal here, this, but it is not equal to f of 3. So it's not continuous at 3. So the limit exists, but f is not continuous at 3. So these are the answers. Sketch the graph of a function f that's defined on R. So the domain is all real numbers and continuous, except for the stated discontinuity. Discontinuities at 0 and 3. So the function is not continuous at 0, okay, at x equals 0. This means that maybe part of the function goes like this, and here we have an open circle and the function goes like this. So this means the function is not continuous at 0 because the limit does not exist. Discontinuity at 0 and 3, but continuous from the right at 0. Oh, so this one has to be closed to be continuous from the right, and this point would be open. This is open. All right. I hope it's clear. Okay. This is open. Now, and from continuous from the right at 0 and from the left at 3. So this is 3, so it has to be continuous at the left of 3. But at the right is not continuous. So let us look to this function. Does it satisfy the conditions? The function is not continuous at 0 and 3. Okay. Is it continuous from the right at 0? Yeah, from the right it's continuous. And it's continuous from the left at 3. So that's it. This graph satisfies all the conditions. course, you can figure or think of another graph that's continuous, that the domain is R, but it satisfies these conditions. Explain why the function is discontinuous at the given number A. Sketch the graph of the function. Well, this function is not continuous at -2 because f of -2 is not defined, because 2 is not in the domain. The graph of this function, we know the graph of 1 over x, but now x plus 2, so we will take the graph 2 units to the left. So this would be a vertical asymptote, and this would be a horizontal asymptote, and the graph would be like this. This function at -2, he says why it is not continuous at -2. Well, it is defined at -2 because f of -2 is 1. But let us make sure that the limit exists. So let us find the limit when x approaches -2 from the right. Well, from the right or from the left, you will always use this definition. Okay, so uh, we will always use 1 over x plus 2. But we need to find it from the right or from the left, because it would be 1 over 0, and it could be positive infinity or negative infinity. So if you approach -2 from the right, you will replace x by -1.9, for example. So it will go to infinity. While limit f of x when x approaches -2 from the left of 1, let me write immediately 1 over x plus 2. In this case, we will use a number -2.1, so the limit would be negative infinity. So it's not continuous because the limit does not exist. Okay, so since limit when x approaches -2 of f of x does not exist, this means that the function is not continuous at -2, although it's defined at -2. What would be the graph of this function? Well, similarly, at -2, I have a vertical asymptote, and I have a horizontal asymptote here. And look, when x approaches -2 from the right, it goes to infinity. The same graph we graphed up. And if x approaches -2 from the left, the function approaches negative infinity. What is new here? F of -2 is 1. So -2, here there is a closed circle. Okay, let me remove the asymptote for you to see the graph. So that's the only difference. At -2, f of -2 is 1. There is a closed circle here, means that f of -2 is 1. But still, the limit does not exist. So it's not continuous. Why this function is not continuous at -1? Well, it is defined at -1. F of -1, I replace here -1 plus 3, that's 2. But does the limit exist? So let us find the limit when x approaches -1 from the right. Once you have a piecewise function, you need to go from the right and from the left. From the right, greater than -1. So the definition would be 2 to the power x. Replace x by -1, 2 to the power -1, or half. Notice that half is not equal to 2. So the function is not continuous from the right. If you approach x from the left, or if x, sorry, approaches -1 from the left, then the function, the definition would be numbers less than -1. So we will use x plus 3. When replacing x by -1, we get 2. So notice that this equals f of 2. So the function is continuous from the left, okay? But in general, the limit when x approaches -1 does not exist, and that's why f is not continuous at x equals -1 or a equals -1. Did he say sketch the graph? Okay, so let us sketch the graph of this function. I'll try to do it here. Well, -1 is the important number. To the right of -1, I sketch the graph of 2 to the power x. So here, y equals 2 to the power x. 2 to the power -1 is half. So it's here half, but -1 is not with it. So this is an open circle. At 0, it is 2 to the power 0 is 1, and it goes like this. We know the graph of the exponential function. While to the left of -1, the graph is a line. So when x is -1, it is 2. So this is half, this is 1, and this is 2. So it's a closed circle here. And if x is -2, 3 plus -2, that's 1. So the graph is like this. So this is the graph of this function. It's clear that it's not continuous at -1, but it's continuous from the left. Let us graph this function. Okay. And from the graph, answer the questions. So 0 is the important number here. At 0, it is 0. So f of 0 is 0. So there is a number here. F of 0 is 0. When x greater than 0, we need to graph y equals 1 minus x squared. If x is 0, y is 1. So y is here. And it's open because 0 does not belong to this part. And if x is 1, y is 0. And you know that this is a parabola, opens downwards, so the graph is like this. But we need this part only, okay? Because we need to graph it when x is greater than 0. Now cosine x, if x is less than 0. Well, x is less than 0. Cosine 0 is 1. And it is open here because also does not belong. And we can sketch the graph of cosine at -π/2 because we have to graph it here. If this is 1, okay, -π/2 is somehow greater than 1. So it is at -π/2, it is 0. And you know the graph of cosine will continue like this. Okay. So it goes like this. So this is the graph of this function. Now, where is it not continuous? It's not continuous only at 0. And why it's not continuous at 0? He said it's not continuous at 0, but he's asking why at x equals to 0, because since the limit of f of x when x approaches 0, what is the limit? It is 1. It's clear that the limit when x approaches 0 from the right or from the left is 1. If you find it also from here, cosine 0 is 1, 1 minus 0 is 1. But this is not equal to f of 0, which is 0. And that's why f is not continuous at x equals 0. Of course, you can find the limit, or not from the graph, but from the definition here. When x approaches 0 from the right, okay, you replace f of x by from the right, x greater than 0 by 1 minus x squared. 1 minus 0 is 1. And also the limit from the left when x approaches 0 from the left. So we use x less than 0, and the definition would be cosine x, and cosine 0 is 1. So the limit from the right equals to the limit from the left. So the limit is 1, but f of 0 is not 1. So that's why it's not continuous. Show that f has a removable discontinuity at x equals to 3. Well, it will have a removable discontinuity uh, either if it is not defined at 3, or if the limit when x approaches 3 of the function is not equal to f of 3. This means that we can define we can make the limit equals to f of 3, and we make it continuous. So let us find the limit of the function when x approaches 3. All right. If you replace x by 3, you get 0 over 0. So we need to factor the denominator, and these two will be cancelled. And now we have 1 over 6. So the limit is 1 over 6. And f of 3 is not defined. This is not equal to f of 3 because f of 3 is not defined. So this means that it's removable. The discontinuity is removable. We can remove this discontinuity. How? Redefine f of 3 so that the function is continuous at x equals 3. So I'll make it continuous by defining a new function. Let me call it g of x. Okay. I'll define g of x to be what? It's equal to f of x, which is x minus 3 over x squared minus 9, when x is not 3. But if x is 3, I will put it 1 over 6. So in this case, g of 3 would be 1 over 6. It will not be undefined. And the limit in this case, which is this one, the same, would be equal to 1 over 6, would be equal to f of 3. So it would be continuous, and the discontinuity is removed. Show that this function is continuous on negative infinity and infinity. Well, f of x is continuous on negative infinity to 1. Okay, since y equals 1 minus x squared is continuous on R. It's continuous on its domain, if you remember. Okay, and f of x is continuous on the interval 1 to infinity here, since ln x is continuous on 0 infinity, its domain. Its domain from 0 to infinity. And 1 infinity is part from 0 to infinity, because this is 0 and this is 1. So if it's continuous from 0 to infinity, it has to be continuous from 1 to infinity. So my problem is at 1. I need to make sure that the limit of f of x when x approaches 1 is equal to f of 1. So let me find the limit from the right of 1. In this case, I'll use ln x. ln 1 is 0. So the limit to the right of 1 is 0. What is the limit when x approaches 1 from the left? In this case, I'll use 1 minus x squared. That would be the definition. When replacing x by 1, I also get 0. So I notice that the limit of the function when x approaches 1 is 0. And what is 0? 0 is f of 1. Because here, if I ask you to find f of 1, it would be 1 minus 1, which is 0. This means that f is continuous at 1. So it's continuous from negative infinity to 1, and from 1 to infinity, and at 1. So this means that f is continuous on R or from negative infinity to infinity. Find the numbers at which f is discontinuous. At which of these numbers is f continuous from the right, from the left, or neither? Sketch the graph of f. Okay. I have to check at 0 and at 1. So limit when x approaches 0 from the right of the function f of x would be equal to the right of 0 greater than 0, I'll use e to the power x. E to the power 0 is 1, so the limit is 1. What about the limit when x approaches 0 from the left? So I'll use x plus 2, and the answer would be 2. So the limit when x approaches 0 of f of x does not exist. Then f is not continuous. Not continuous at x equals 0. Let us check 1. Let us find the limit of the function when x approaches 1 from the right. When x approaches 1 from the right, I'll use 2 minus x. 2 minus 1 is 1. While the limit of f of x when x approaches 1 from the left would be, in this case, less than 1, I'll use e to the power x. E to the power 1 is e. 1 is not equal to e. So limit f of x when x approaches 1 also does not exist. So f is not continuous at x equals 1. Okay. He said from the right and from the left. Well, at 0, f of 0 is e to the power 0, which is 1. So here, this is equal to f of 0. So it's continuous from the right at 0. While here, the equality is here. So f of 1 is e. So e is f of 1. This means that the function is continuous from the left of 1 and from the right of 0. And now we just need to sketch the graph of this function. We have two important numbers, 0 and 1. Let us start by 0. Graph to the left of 0. To the left of 0, the function is y equals x plus 2. At 0, it is 2, and it is open. And at negative 1, okay, it is 1. At negative 2, it is 0. So this is the graph of the line. To the left, this is x plus 2, to the left of 0. Between 0 and 1, there is equality, and the function is e to the power x. So e to the power 0 is 1. It's closed here. And at 1, e to the power 1 is 2.7, so it's here. So this is the graph of e to the power x from 0 to 1. 2 minus x, I graph it when x is greater than 1. If x is 1, 2 minus 1 is 1, so it's here, and it should be open. If x is 2, 2 minus 2 is 0. So it would be the graph of this line. So this is the graph of the function. As you can see, at 1, it's continuous from the left. At 0, it's continuous from the right. But anyway, in general, the function is not continuous, neither at 0 nor at 1. For what value of the constant c is this function continuous on negative infinity to infinity? Well, it is continuous to the left of 2 because it's a polynomial. Continuous to the right of 2 because it's a polynomial. So it's continuous everywhere except possibly at 2. So let me find the limit of f of x when x approaches 2 from the right. Well, from the right, what would be the definition of the function? We need x greater than 2. So it would be x to the power 3 minus cx. So it would be 2 to the power 3, 8 minus 2c. The limit of the function when x approaches 2 from the left, x less than 2. So it would be the limit of cx square plus 2x. Replace x by 2, 2 square 4, 4c plus 2 times 2, 4. So this is the limit of the left and that's the limit of the right for the function to be continuous. F is continuous on negative infinity to infinity. F 8 minus c equals 4c plus 4 because then the limit exists and equals to f of 2 and it would be continuous everywhere. So let me take 2c here, so I'll have 6c, 8 minus 4 here, so I'll have 4. So the value of c would be 4 over 6 or 2 over 3. So this value will make this function continuous on R. That's the end of the exercises. I hope you enjoyed. Thank you very much.